Hello dear students. So today we will be doing a new series, that is division algorithm of polynomials. The series has been divided into two parts and this is the first part of the series. In the series we will be doing, or we are expected to learn, the following things. The first thing is relate division algorithm of polynomials with division algorithm of integers. The second thing that we will be doing is verify division algorithm of polynomials. And the third thing that we are expected to learn is apply division algorithm to find the missing components. So let's start. Let us see what division algorithm of integers actually is. It is a relation that binds or combines the four components of division: dividend, divisor, quotient and remainder in the relation dividend equals to divisor into quotient plus remainder. In order to verify this, let us take an example. So for example, we are taking two integers, two positive integers, 5 and 47. For that matter, you can take any other example, any other positive integers and still verify the algorithm. So we are taking 47 as our dividend and 5 as our divisor. So let us divide. Now in order to divide that, we'll take 5 nines are 45, as 45 is the multiple of 5 which is closest to 47. Now we will subtract and we will get the remainder equals to 2. So we have got all four components of our division: dividend, divisor, quotient and remainder. So we have got all four components of division. Let us now see whether the verification or the relation works or not. So 47 dividend equals to 5 divisor into quotient 9 plus remainder 2. Remember BODMAS, first multiplication. So 5 nines are 45 plus 2. So 45 plus 2 will give us 47. So dividend equals to divisor into quotient plus remainder has been verified. That is, division algorithm of integers is verified. Now remember, we had done similar assertion in the first chapter wherein the name was Euclid's division lemma, wherein we had said a is equals to bq plus r for some integers a, b, q and r, wherein r has to be greater or equals to 0 but less than b. Now let's see what the relation looks like for polynomials. The result is true for polynomials as well, but is expressed with the help of some notations: px for dividend, gx for divisor which cannot be 0, qx for quotient and rx for remainder. The statement for division algorithm of polynomials is: for any two polynomials px and gx, wherein degree of px should be greater or equals to degree of gx. That means degree of px should at least be equal to degree of gx or greater than that, and gx should not be 0, then there exists two polynomials qx and rx such that px equals gx dot qx plus rx. So if you can see, the division algorithm for polynomials is also exactly the same as division algorithm of integers, but it's just that the notations are used differently. So this is our division algorithm of polynomials: dividend, divisor, quotient and remainder. So now let's verify this relationship with the help of an example. Let's verify the algorithm by solving an example. The question is: divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square and verify the division algorithm. As you can see, the degree of the first polynomial is 3, the highest power is 3, and the degree of the second polynomial is 2, the highest power is 2. Both the polynomials are not arranged in the order of descending order of power of the variable. So the first thing is, we will arrange both the polynomials in the descending order of the power of the variables, like this. Now see, px has been arranged in the descending order of the power of the variable: minus x cube plus 3x square minus 3x plus 5. It was not arranged, so we have arranged it now. Similar thing with gx. gx was also not arranged, so we have arranged it as minus x square plus x minus 1. It was also not arranged, so we have arranged it now. Now let's divide. So as you can see, the quantity with the highest power in the dividend is minus x cube, and in the divisor we have minus x square. So we need to figure out minus x square into which quantity can give us minus x cube? So by now you must have figured out that quantity is x, as minus x square into x can give us minus x cube. Now there are two more quantities in the divisor, so we need to multiply them as well with x. So we'll do that. X into x will give us plus x square, and minus 1 into x will give us minus x. Now the next thing is we will subtract them. Subtraction, change of signs. Minus changes to plus, plus changes to minus, and minus has changed to plus. The first quantity, they are equal and opposite, minus x cube and plus x cube. So they'll cancel out each other. Now we will operate with rest of the quantities. Plus 3x square minus 1x square. 3 with the plus sign, so plus sign will carry on. 3 minus 1 will give us 2x square. Next case, minus 3x plus 1x. Again, now here 3 is the bigger number but with a negative sign, so negative sign will carry on. Minus 3 plus 1 will give us minus 2x, and plus 5 will just come down. So we will get 2x square minus 2x plus 5. Now our focus will shift to 2x square. Now we need to cancel out 2x square. Minus x square into which quantity can give us plus 2x square. So the first thing is minus sign is there in x square, so we need to take care of that. Minus into minus definitely we need to do in order to get the plus sign, and 2 into x square will give us plus 2x square. So we will do multiply with minus 2, as minus x square into minus 2 can give us plus 2x square. Similarly, we will multiply with the remaining things of the divisor. Minus 2 into plus x will give us minus 2x, and minus 1 into minus 2, minus into minus plus, 1 to the 2. Now we will subtract. Change of signs. The first two quantities, they are equal but opposite in sign, so those two quantities will cancel out. 5 minus 2 will be 3. So we are done with the division. We have got quotient qx as x minus 2, remainder rx as 3, and remember we had dividing px equals to minus x cube plus 3x square minus 3x plus 5, the arranged form, and gx minus x square plus x minus 1. These two quantities were given to us. Now let's do the verification. Let's verify the division algorithm for polynomials. The thing that we need to prove is dividend px equals to divisor gx into quotient qx plus remainder rx. So as you can see, our right hand side is much more complex. It involves 3 quantities. So we will work on the right hand side and we will try to get same thing as left hand side by solving the quantities in the right hand side. So we'll start with our right hand side, which is gx dot qx plus rx. Let's put the values of each quantity, each component. Gx was minus x square plus x minus 1, qx x minus 2, product of the two, plus remainder 3. Now as you can see, gx has 3 quantities. It's a quadratic polynomial, it has 3 quantities, and qx has 2 quantities. So I'll multiply qx with gx. First I'll multiply x with all the quantities of gx, and then I'll multiply minus 2 with all the quantities of gx, like this. X into minus x square plus x minus 1, first with x, then minus 2 into minus x square plus x minus 1 plus remainder 3. So the first product will give us x into minus x square minus x cube, x into x the x square, and x into minus 1 minus x. Now similarly in the second bracket we have got the second product, minus into minus plus, 2 into x square is 2x square, minus into plus minus, 2 into x is 2x, and minus into minus plus, 2 ones are 2, and plus 3 the remainder we have. Now let's open the brackets. So we have opened up the bracket and we have also placed the like terms together, minus x cube, since it was the only thing that had x cube, so only thing that had power 3, so we have kept it aside. X square and plus 2x square, they were like terms, so we have brought them together. And minus x and minus 2x, they were also like terms, both had variable x, so we have also brought them together. and obviously constant 2 and constant 3 together adding. So if we'll operate, we will get minus x cube plus 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 2 plus 1 3x square minus minus plus with the minus sign, carry on. 1x plus 2x will give us minus 3x and 2 plus 3 will give us 5. And if you can see, this is exactly equals to our px. So the division algorithm of polynomials is verified. Now let's watch part 2.